Hello, everyone. It's live stream number 23 today, and we are welcoming Kevin Kripper from Argentina. Hello, Kevin.
Hi, JB. How are you? Thanks for having me here.
Well, I'm very pleased to have you, and you're already displaying some very interesting effects, and I think we will see more of this. So, a quick introduction, and you can complete that. So, you're based in Argentina. You're looking to continue studying and practicing in the US. Maybe this year, maybe the next one. You are the author of Vsynth, which is a package that everyone can get from Max as long as they have a license. They can download the package; it's free. And I checked, and it's one of the most popular package
Thank
for
you.
that cycling students who are distributed. I mean, just in terms of download, I think it's the third most downloaded package and the first one in the video section.
That's crazy. I didn't even know that there were 13,000 downloads. I mean, it is
So
crazy.
yeah, it's very good. Congratulations. How did you
Thank you.
start building Vsynth?
Well, I started in 2016. After really, it was after seeing Lumen app, which is a semi-modular virtual video synth. And when I saw it, I thought, hey, I can make something like this, and I can use Max. I can make it modular, and I just dive into it and never stopped since that time.
Well, this is great. Congratulations on this, and I'm looking forward to seeing more of what you've built. So, if you join us from Facebook, YouTube, or Twitch, you are most welcome to post comments, ask questions to Kevin. You might not be able to see them, but I'll keep track of those and bring them to the attention at the end. So, Kevin is going to give us an overview of his work, and which you already are seeing right now with effects on his background and face. This is all built with VSynth, and he'll get to that in a moment. Also, let us know. Today is focused on video, but let us know any questions you have with regards to that. If you're a video performer, if you have questions about installation, about offline videos, about performance, about connecting to MIDI, all of this are topics as well that he will address in a series of 4 workshops starting Wednesday, 8th of July. And every consecutive Wednesdays is going to deliver a 2 hours workshop, which you can buy as a whole or independently. So please ask questions in the chat, say hi, and we always love to hear from you. And on this, I'm going to retreat and give this over to you, Kevin.
Okay, thank you, JB. Thanks everyone for tuning in. Thanks also Darwin, who actually was the one that introduced us. So a big shout to him. So yeah, what you're seeing now, it's my face with a Vsynth patch on my background that I'm going to show you right now. So you can see what's Vsynth about. All right. So Vsynth are these series of modules that run in Max. They are all built around Gen, so inside of them, they are all fragment shaders running. And well, they are organized to be a video synthesizer, which means that you have generators and processors that are pretty similar to the ones that you will find in an audio synth, but instead of creating sounds, they create image. Um, so here we have a patch, which I'm going to delete the siphon output because, I'm just sharing my screen now. And as you can see, I mean, with really simple modules, really little modules, you can start creating some complex video feedback stuff, like the one I'm creating here. I'm going to erase myself a little bit so you can watch it better. Right. So this is not going to be a tutorial on Vsynth because, as JB says, we are going to have 4 workshops starting next week, in which I'm going to cover a lot of what's Vsynth about. There are more than 80 modules now to interconnect and start creating stunning visuals in real time. So yeah, so I mean, if there's any question about this video feedback thing already? I don't think so. Okay, So I'm gonna erase all this and start a patch from scratch. I'm just using this to start the live stream with some cool stuff on screen. But if you never use Vsynth, you wanna download it from the package manager and then go to extras and open the launcher here, which is this little menu that have some options. One of them is the about. The about tell us a little bit what's Vsynth about, and you have here a three modules patch, which I like to call them the Vsynth haiku. Uh, which I mean, it's that there's three modules that are making some pretty funky visuals here, and it's amazing because with just three modules, you can go from this kind of noisy video feedback thing, but then you can, you know, change the waveform, and you can have more smoother visuals, and you just change the waveform and adjust a little bit the filter here. But anyway, with just three modules, you can actually make a lot of different things, a lot of different aesthetics, just to show a few here. And yeah, there are three modules only. And I know Rob has been talking about this in his live stream, but just going to uh, go through the launcher a little bit. If you never use Vsynth and if you want to dive right now or after the live stream, so yeah, you can start a new patch. You can start patching from scratch here. You can add modules, and you know really simply you can just start creating different patterns. But before diving into some patches, because I don't want this to be a tutorial, so I'm gonna go through the launcher a little bit and then start patching some new stuff from scratch. I just realized you're not seeing me anymore, so I'm gonna add this picture-in-picture thing so you can actually see me. And so, yeah, you have a lot of lessons here to go through. I think I cover mostly everything in Vsynth here, but there are some stuff of course, that aren't covered. But there's a lot to explore just in the lessons, and there are also some patches here which are you know gathered together in this thing which I call the patch book, which are a lot of different patches that explores different aesthetic possibilities you can do with Vsynth. Let me just show you a few. For example, the first one is the DX6. And I call it this way because this is actually the sixth algorithm from the DX7 synthesizer, with some particularities. For example, this operator, which I have here, a waveform generator modulating the phase of another one, and they are creating a feedback loop between them. And for example, in the DX7, you actually don't have a low pass filter here in the feedback loop of this algorithm. But since we are not creating sounds, we are creating images. Some stuff has to be changed in order to create, this particularly things in the feedback. If you don't add a low pass filter, a blur, you will get a lot of noise, and maybe that's something not expected. So again, since we are working here with image, there are some things that are similar to audio, but there are other things that are just from this medium. So again, this is the sixth algorithm from the DX7, but producing images, and you can have here some presets and go to the different possibilities this patch can create, and which goes from this kind of smooth colors and going to this kind of dune sand thing, desert uh, landscape. Then you have some more feedback noise here. And again, a lot of different aesthetic possibilities. So the same patch can create these lines, but also can create this your feedback thing. So it is pretty interesting to see how with really little modules, you can create a lot of different engaging visuals. So let's go to another of the patch book. I mean, there's quite a few here. You got the modular grid, which just creating a grid. Then you can modulate it that grid with a circle. You go through different possibilities. Some patches are simpler than others, and they are in order. Actually, you can create some hearts. Some scrolling hearts here, some diagonal scrolling hearts, and yeah, and then you can create some more complex things, like for example the folded colors patch, which is more big, has more modules, but actually the graphics is creating, they are much more beautiful than the others I was showing. And it's pretty crazy. Again, with one just patch, never mind the amount of modules you have, you can actually go through a lot of different aesthetics and just playing around with the knobs and all that. So again, a lot of different aesthetics branches from the same patch. Let's just go through some more of these ones. Gonna add here the Luma displacement, which is a patch I like a lot, which creates this fluid kind of acrylic painting. And you of course can interact with these patches, right? Just turning a little bit the knobs here, the feedback. And there you have a lot of presets to continue exploring this patch. And let me just show you one more, which is, this one actually is a branch from a user's suggestion, which it is kind of a massive patch. It is kind of big, but it creates truchet tiles just with Vsynth, which is kind of, I was really impressed when I saw this patch, and I just modified it a little bit in order to get, more and more truchet tiles, kind of lattice patterns with the same amount of modules, just changing again their parameters. So here you can go through a lot of different truchet tiles. Some of them are kind of famous. Other ones are just, inventions here. Like, I'm sorry, this one. Oh, I lost the preset. Okay, this one is a classic truchet tile pattern. Whereas, I don't know, this one or this one are more, kind of an invention that branch from this patch. And there's something that you might notice, that every time I click out of this patch, everything goes black. And that is because every patch in the launcher is not able to unlock, which it is intended. It's not a flaw. And I did this in order to, open as many patches from the lessons and patchbook you can without killing your machine, and also so you don't just copy paste and you actually patch everything again, and learn and understand what you're doing with which. It's my goal is that you learn video synthesis through Vsynth, and not just copy paste and make some funky visuals. And so in that sense, let me just go through some lessons. So the idea here is that you have both lessons and help files here, which I might change in the future just for lessons. And so I don't know, let's go to mixers one, for example. So this opens here a patch. Um, I don't know, JB, if you are watching this, I mean, if the letters
Of
are,
course, I'm here.
you can
I'm
read,
here.
you can read everything.
You could possibly do it a little bit. No, it's fine. I mean, I can read it with
Okay,
my glasses.
cool. Right. Okay, perfect. So this is the Mixers one lesson in which basically, teaches you how to use an additive mixer, which is just summing signals. We have here three oscillators. I'm going to, you know, uh, go to the oscillators in a bit. Just try to follow me on this one. But you have here three oscillators going through three colorizers. So each, I mean, I can colorize the signals differently, and then it's all going through to a mixer, which is just add signals together. So as I was saying, if I click out of the patch, everything goes black. So the idea here, when you are doing the lessons, if you have never used Vsynth and you want to, dive into this, you can go to New Patch, and when you are in New Patch, you can actually, copy what you are doing in the lesson. So I have one, two, three oscillators here, go into three colorizers, and then I'm sending everything here to an additive mixer. So let's just, select a preset here from the class, from this lesson. Let's just grab someone like this one. I don't know. So once you're here, we are in preset 5. Preset 5, it says different waveforms will give different gradients. Anyway, let's just see if we copy this same preset in a new patch, if we can get the same result. So first oscillator, its frequency, it's 283. Second time, and I have here a sawtooth instead of a sine wave. In the second waveform, I'm using a square wave, and the frequency is 71, and it's an horizontal square wave. And the third waveform generator, it's ramp, and its frequency is 543. And I'm going to, turn this up. And I'm not having the same because I haven't colorized my image just yet. So first colorize is yellow, the second one it's almost cyan, and the third it's pink. And there's something I haven't done okay because it's not the same. So ramp, 200, horizontal. I'm getting closer, as you can see. Or maybe I'm there. I think I'm there. Yeah. All right. So this is why basically the patches aren't unlockable. So you actually copy the patches from the lessons and try yourself how to patch Vsynth and how, get your own conclusions on what you're doing here. So it's really important to me that you patch and not just, copy paste and drag and drop things around. So yeah. So that's the lessons. There are a lot of lessons. Each of them has different tabs with different text and presets to get you through all the more than 80 modules. I'm just going to go through some more lessons just to show you. But, basically what I've said, they are all unlockable. So you need to patch them in order to continue using these lessons. But for example, we can go to the slit scan, maybe the slit scan tab, which actually goes through the spatial sample and hold module, which basically it samples the image every time. I don't know if you can see the white. There's a white pulse here. Okay, it samples the image when it's white, and it freeze that frame, all the time it's black. So as you can see, the webcam freezes for the period. You can see black here in this preview monitor I have here. Um, but for example, if you change this, you know, this impulse here for an actual line, which I'm going to increase the frequency of this pulse waveform. And as you can see, if I, slow down a little bit the line, you can see that now it is sampling the whole row of pixels where it is white, that is in the white line, and then it is, maintaining that freeze frame um, in all the screen, which is black. As you can see here in the preview monitor, it is freezing, it is sampling the image, the row from the white stripe here we have created, and then it is freezing all that time in the screen. So you get this, this pretty common effect, which is called slit scan. There are some more ways to do this. They are covered in the slit scan 2 lesson, and there are tons of patches to explore here. And I don't know, I'm gonna go to finger feedback, for example,
Is it
in
okay to
which,
interrupt you for a second, Kevin?
yeah,
Because I have a question. I mean, you did touch on it earlier, but I was wondering if you could explain the fundamentals of video synthesis, because it bears so much resemblance with audio synthesis, but obviously it's for a different medium. So you don't have to answer now, but I'd be very interested in knowing more where that came from, and where to look for arts that's made with video synthesis.
right. So I mean, video scenes come from the MOOC modular in a way. They copy all the CV's input and the logic from the MOOC modular and from earlier analog computers, and they were calibrated from image, and that means that the chips they were using are bandwidth. I mean, they have a bigger bandwidth because audio goes from 22 kilohertz, 22K, um, and video goes to up to megahertz. So that's a difference you have there. Just let me finish a little bit with the lessons, just to,
Of course, yes.
and then I go with the oscillators, which I think it's the best way to understand maybe the differences.
Great,
Um,
thank you.
you're welcome. Yeah, I mean, here you have the phase modulation lesson, which, I mean, there's the, the feedback into a phase modulation system. And yeah, again, you have in every lesson, you have tabs with presets and text to explain what's going on so you can understand better, and take advantage of all the modules and possibilities that Vsynth allows. So that's the launcher. I'm not going to go deeper with this because you can just download and dive yourself into all this stuff. And I'm gonna start a patch from scratch like I use to do every day. So I'm just going to open a max patch. And the way to, yeah.
It's a good time for me to just bring up a question just from Dash. Thank you, Dash. Who would love to know how the various waves synthesized correspond to what's displayed on the screen. So, just as you explain the next bit, if you can relate to how the synthesis works with what's displayed.
Right. So let me just create a default patch here, which brings the most basic Vsynth modules, which are the menu. There are all the modules hosted, and you can add them. The waveform generator too. I'm going to go to it in a sec. The colorizer, the corner pins, which connects the modules with the render window, the render module, which turn on the system, and it's the most important module because without it, things doesn't work. And then we have here a preset storage thing. Okay, so oscillators. Let's go with the question here, which is the various wave synthesizers correspond to what's displayed on the screen. Okay, perfect. So here we have a sine wave, and I'm going to add a scope here, which it's going to show kinda time and amplitude. Okay, just like in audio. All right. So I hope this brings a little more bright to what I'm doing here. Okay, so in audio we have time and amplitude basically, and here we have time, amplitude, but also space, because we are, we are not moving the cone of a speaker. We are just, filling with color different pixels on the screen. So it can be thought that this is not what's going on, but you can think of this like you have two frequencies actually. The frequency which is creating lines or cycles of the waveform in screen, which is the frequency, when you sweep the frequency in an audio oscillator, you hear the pitch change, and here you can see that we are adding more cycles of the waveform, right? But there's another frequency, which is the time, which is the scrolling speed of this waveform on the screen. So here the time is in 0, so it is stopped. But you can see that if I put it in 1, I have a scrolling lines, which are sine waves, going from left to right. So this is the sine wave. We have also the triangular wave, the sawtooth, the ramp, the square wave. And when you hit the square wave, you can unlock here the pulse width knob, which change the pulse width, as you can see both in 2D or in 1D in the scope. And also you can get access to the pulse width modulation. And of course you have also a noise here, which is not a normal white noise. There are some generators. There I have another white noise, just a simple module here, which creates static. But here in the waveform generator 2, you have this noise, which it's creating a lot of lines which have random amplitudes or brightness, basically. And you can create it in diagonal, horizontal, vertical, etc. Let me know, JB, if that answers the question. But basically, you can plot the waveforms in this visualization, like in the scope, which is basically time and amplitude in audio, but here can be space and amplitude, and then you have this basically replicated in every row here, and make the sine wave like in a standard video synth or GLSL.
Yeah, Dash says it was great, so no complaints there. There's a next question that's I think very interesting. You don't have to answer now. Whenever in your flow, it works. But someone would love to see gentle return. Would love to see examples of audio reactive visuals, and I think this is a big part of what Vsynth is for. So having an example at some point would be great.
Okay, that's fine. Yeah. So anyway, as I was saying, the thing here, I think mostly as I have two frequencies, which is not exactly like that in the analog video synth world, but I would go deeper in that in the workshop. But here, just to make your mind, you have the frequency that controls the amount of cycles on screen, and you have then the time, which controls the scrolling speed of your animation. For example, I have another waveform generator. I have a lot of waveform generators, but here is the waveform generator 3, which, as you can see, it's different like the 2, because I don't have switches. There's all knobs. So, for example, here it starts on a sine wave, but then I have a shape knob, which I can take it to square wave or triangular, or then to the sawtooth, which is pretty handy because now I can, interpolate between waveforms, and instead of going to the different waveforms in a fixed way, I just scroll um, between all of them. And of course, here I don't have, since it's everything a knob, I don't have here fixed angles, but I have here a knob, which is the angle, the rotation. So it's a little bit different. If you are interested in how analog video oscillators work, you can go to the AB waveform generators, which is an unsync video oscillator branch from an audio oscillator, which means it actually starts when you are not in multiples of 60, which is the refresh rate of the screen. It starts scrolling up and down, and it only creates new cycles when you are fixed cycles when you are in multiples of the refresh rate of your screen. This is the only one I have, which is more kind of analog um, video oscillator, and not 100% digital as all the rest I have here in Vsynth. But that's, I think, is gonna be a topic for the first class of the workshops. So I'm gonna stop there, and I'm going to start patching a little bit some stuff to show the different things you can do with Vsynth, and how easy it is to to suddenly have some stunning visuals. So yeah. So I'm gonna start with shapes waveform generator, which it doesn't create stripes. It creates different geometric shapes. With with the waveforms. Let me explain this. I'm creating here a square with rounded corners, a triangle, and these shapes, but I'm drawing it with a sine wave here, or a square wave, or you have the same waves to draw. In this case, instead of lines, actual geometrical shapes. So I'm gonna go with a triangle, which I like. I'm going to stop time. So now I have a fixed um, triangle. I'm gonna put it in a square wave. So I have stripes, just delimited things, and I'm gonna turn down the frequency, so I have just one triangle and not a lot of repetitions of the triangle, right? So I'm gonna take this to 30 hertz, and going to to decrease the pulse width a little bit. Yeah, I think that's gonna be okay. And I'm going to add another folk here, which is something that I didn't explain, but just so you can see it, I'm gonna add a preview here, which is something every video scene should have, which is a lot of previews to see actually what you are doing. And I'm gonna add here also a scope, so you can see that the LFO is, when we were just a second ago debugging the waveform generator, as you can see, I have here a lot of lines, a lot of cycles of the sine wave. But what happens if I set that to 0 is that all the pixels in the screen are behaving the same way. That is, every pixel in this screen is going it's cycling between 0 and 1 with this gradient, and every pixel is behaving the same way. So this is how a video LFO looks like, which differs of, if I put this the knob frequency in other values, you actually have um, different behavior for each pixel on your screen. You have some pixels that are black, which are the valleys of the sine wave. You have some other pixels that are white, which are the peaks of the sine wave. So when you start actually modulating stuff, it's gonna be really different if you use a gradients like I'm doing here, which I mean we can think of these waveforms, these cycles of the waveform as a gradient, or we can basically um, put it in an LFO and all the pixels will behave the same way. And I'm just going to show you how frequency modulation looks like in order so you can follow me, because there might be people that haven't used Vsynth. And so anyway, I'm gonna do this just for educational purposes only, and then I'm going to continue. So I have here an LFO, and I'm going to modulate the frequency of the other waveform generator. And as you can see, the first inlet, it says frequency modulation in, a control in. So I'm gonna put the output of my waveform generator into the FM input of my other waveform. And basically, when we modulate a frequency with an LFO in audio, we hear the pitch shifting, right? So in the video world, that would mean that we see more and less cycles of the waveform, right? It's like moving the knob frec by hand. So I'm going to open here the FM knob, which is an attenuator. So I'm going to put this in 1, and as you can see, now the cycles of the waveform are adding automatically with this LFO, and I can change the speed. Yes, I can change the speed, and it's going to be faster or slower. And also I have here a button that toggles different range for the knob, so I can multiply the signal input by a higher number, and then I have this is like my modulation depth, but this really changes when you feed the frequency modulation input, not with an LFO, but actually with a gradient or with a higher frequency, yeah, with a higher frequency. So I start up, yeah, so my modulator oscillator now is at 130 hertz. So it's spitting this sine wave, and you can see that the modulation actually changed now the pattern I was getting out of my, let's just call it carrier. So what happens if I put my modulator in horizontal? Okay, so that happens. And this is how frequency modulation looks like in video. Just, really quickly, just to, so you understand that now I'm going to modulate the pulse width of the triangle with an LFO. The same, I can do it here. I can just, plug the LFO here to the modulation input of the pulse width, and it's actually just modulating the pulse width automatically. So okay, so I'm going to, as I was saying, modulate the pulse width of the square wave that is creating my triangle here. And that is going to happen, which is perfect. But I don't want a sine wave modulating this parameter. I want just something more random. So I can here set my LFO to sample and hold. And let's just speed this up a little bit. So yeah, now I have random values changing my pulse width of the square wave that is drawing the triangle. Awesome. I really don't like this steppy thing going on, which is kind of hard. I want something more smooth. So we can smooth values with the temporal low pass filter, which is here. If you're a jitter user, this is like the jit slide object. And as you can see, it automatically, let's just add a scope here and a preview so you can, compare with what's going on with the LFO. So the LFO, as you can see, it's really steppy. And after the temporal low pass filter, you can see that it's not, going hard in one step and another one. It goes smoothly, go through all these random values. It's something that I wanted to achieve, which is perfect. So yeah, so we have now a beautiful pulse width modulation for our triangle here. Right. So, okay, another thing I would like to do now, and just to show you something else about Vsynth, is that everything in Vsynth can be controlled externally with max messages, as in every other object. So let's do something like this. Let's grab another LFO, and as you can see, the LFOs have two inputs. Two outputs, I'm sorry. The first output is a texture output, which is basically an image, right? It is spitting this image. But the other output is spitting a number, which goes from 0 to 1. And we can actually see this number by adding this snippet I have here in paste from Vsynth extras. We can here grab the data scope module, which is this simple snippet that allows us to visualize numbers going from 0 to 1. And as you can see from the LFO, now it's coming out a number that goes from 0 to 1 in a sine wave shape. And this is going to change. For example, if we plug the data scope to the LFO that is spitting a sample and hold, you can now see that there is that the curve changed, because now it's not speeding a sine wave, it's speeding a sample and hold here. So yeah, so what I'm going to do with this value going from 0 to 1 is to control the rotation of the triangle here. And to rotate the triangle, I'm going to add a spatial transformation module, which is called the displacement. The displacement allows us to offset the image, to scale it, and to rotate it, okay? So as I was saying, each module can be controlled externally. So let me just scale this value from 0 to 1 to 0, 360. And then we can just, let's say, prepend angle. Or, of course, you can add a message angle $1, and it would be the same. I get used to use the prepend instead of the message, so I'm gonna stick to the prepend. And I just have to plug the output of the prepend angle to the input of the displacement module that, as you can see, it says texturing / controlling. So yeah, when applying here, and as you can see, it starts rotating automatically. It's kind of quickly, so I'm going to slow down the LFO a little bit. And yeah, so it's not, I would like this to rotate like 360, like linearly rotate infinitely. And since we are feeding this with a sine wave, at some point it turns back and kind of bounce instead of rotating infinitely. So to make something linearly eternal, we just can change the LFO for a ramp. And now we can see that our triangle is rotating eternally without bouncing, without anything. It just, goes from 0 to 1, that go from 0 again to 1. But since 0 on 360 in the rotation, it's like the same degree. It's like it continues rotating eternally. Yeah. All right. So I'm gonna change the bound mode here, so we don't see black. Let's just put wrap. And we have the circle there, yeah, spinning without stop. That's awesome. I'm gonna do something else here and displace the triangle to upwards. So yeah, so here in this menu I can change the range of my knobs. So I have some tools for fine tuning the modules, and yeah. So I'm gonna put this up. Awesome. And again, I'm gonna wrap this instead of mirroring or clearing. Great. All right. So the next thing to do, and I guess that's one of the most interesting things people um, think Vsynth is that the video feedback techniques. I'm just gonna create some video feedback now, which it's gonna be really simple with a Luma key. I'm gonna grab a Luma key here, and the Luma key, it's going to, I mean, I can do several stuff here. Like for example, I'm gonna grab another waveform and just feed the Luma key with the second input of the Luma key with it. And as you can see, the blacks now are now replaced by the oscillator there. But I don't want this. I just want to replace all the whites with the same triangle but going downwards. And to do that, I'm gonna grab another displacement and I'm gonna feed it with what's coming out from the Luma key. And then I'm going to feed the second input of the Luma key with the displacement module. Okay. And that happens, which doesn't look like what we want. So first of all, I want to replace the whites. And so here I have an invert button in the Luma key, so I'm going to press it. So now it starts cutting out the whites and start replacing the whites with the triangle rotating it. And that looks perfect. And so what I'm going to do here is to displace each iteration of the feedback loop downwards. So let's just do that. And as you can see, it is not perfect. And also we can see each iteration, right? There's all these new triangles appearing. That's because I'm separating each iteration a lot. So I'm going to set the range of my null to 0.01, which is really little. But now I have what I wanted, which is all the iterations going really next to each other and going down. But there's something that I don't like here, which is that I barely distinguish the triangle now because it is, I mean, the stroke was really thin. So it's being cut out by the Luma key. So one way to increase your borders, it's by applying a blur, or in Vsynth terminology, just a low pass filter. So I'm going to add a low pass filter here, which is a simple low pass filter 2x, which is 2 passes. It's like the amount of balls if you want. And I'm going to stick it in between the displacement and the Luma key. And I'm going to filter a little bit the square wave. And as you can see, now the borders are a little bit more thick, so you can actually see them better. And and yeah, so yeah, the first things we accomplish was to create some spinning triangle, creating a feedback loop, and displacing it. So someone asked for audio reactivity, so I think it's a good time for that. So I'm going to, maybe you're not going to hear this, but I'm going to add here the microphone. And here in globals, I have an envelope follower module, which is pretty basic, but it's functional. And I'm going to plug to it the audio in this case, the microphone. And as you can see, I don't know if you can, I'm going to zoom in a little bit, but if I talk near it, as you can see, we have some preview there, and you have an image that goes, it looks like an LFO. Let's go, all the pixels are behaving the same way, and they are going from black to white. It's 0 to 1. And if I talk louder, I'm sorry if I'm, hurting your ears, but just to make a point here, if I speak louder, more white's gonna appear, and you can see also that in the kind of scope that we have. And again, like the LFO, the envelope followers have two outputs. The first output is gonna be the video out, and the second output is going to be the number output, or the data scope that we were using before. So here's a number, and in the other output is video. So in this case, I'm just going to use the video. I'm going to replace the LFO that we are using to change the pulse width of the square wave that is drawing the triangle. I'm just going to plug it to the envelope follower. And yeah, as you can see now, I'm controlling the size, maybe, or yeah, it's not the size, it's the pulse width, but it definitely looks like if I'm like changing the size of the triangle with my voice. Yeah, and there we have an audio reactive spinning triangle feedback going on. In order not to speak near the microphone, I'm just going to multiply the input of the microphone by 5, maybe. Yeah, okay, yeah. So now I can speak normally, and you can see the changes of the triangle. And I have here also a kind of a smoother for the envelope follower. And well, yeah, I mean, this is how you can make some, really easy plug and play audio reactive stuff in Vsynth. Just grab whatever audio you have, or the mic, and just plug into the envelope follower, and then basically connect it to wherever you want to modulate with the audio. Of course, if you're a Max user, you can make a lot of different stuff with this, like filtering, and the different bands can control different parameters, and there's no need to actually use video for this. You can just use the snapshot object to convert audio into numbers, and then just as I did here, to the angle, and control parameters with numbers. Yeah, so that's one thing. The interesting thing here is that, I mean, I'm going to plug yeah.
While you're transitioning to the next thing, I just wanted to plug in a question from Federico, who wanted to see the inside of a random generator, any generator.
Okay, so actually, I'm gonna go to the waveform generator 2. Yeah, there's the interesting thing between developing these modules than developing audio, I think. Well, it's been a while since the last time I built an audio synth in Max, but I remember that I didn't care much about performance, so I was executing, for instance, all my waveforms at the same time. And here, we of course can do that, because imagine I have 6 waveforms per module. Imagine that you have, I don't know, 6 waveform generators. If you have all the waveform generating at the same time, your computer is gonna explode. So at the moment, I just don't care much about the shaders anymore, because they are really easy actually, but there's a lot of work here in the module to make things performant. And so, for example, Here's a GGL Pix object, right? And instead of, of having all the waveforms executing at the same time, I have a shader per waveform, and then I change shaders on the flow. Here I have my list of the different shaders, and for example, I'm a sine wave. I open here, and I have my sine wave, but then I go to pulse, and I go to my GGL Pix again, and I have the pulse algorithm here. So yeah, there's a lot of work um, on this side, and the random generator for the waveform generator too is just a JIT noise, as you can see here. But there are some things, for example, that well, here I have uh, a note for myself: max frequency with max X resolution. So, for example, the knob, the frequency knob here, when it's set to noise, instead of going to 1,000 kilohertz, I'm sorry, yeah, 1K, it goes to up to the maximum resolution you are working on. So, for example, since now I'm working on where's my render, in 640 by 640. So my uh, here my frequency, when it's in the noise, it goes up to 640, which basically means that it's creating 640 lines with different amplitude. And then, I mean, there's just a simple GGL Pix after the JIT noise, which controls here the time, the frequency, and the angle. So I'm just going to show you this again. So I choose noise. So noise now is just a simple JIT noise. If I go with my frequency knob to the most right position, now it's creating 640 lines with different amplitude, each of the lines. And then that is going to a GGL Pix module, which is sampling this and actually rotating, and then to this you can add another waveform, for instance, and change the phase, and you are basically modulating the noise now with a sine wave, and that crazy pattern appear. You can also modulate noise with noise, like a vertical noise, modulating an horizontal noise. Let's see, this is our horizontal noise, and I'm start going to modulate it with vertical noise, and that kind of pattern appear, which it definitely looks more analog than that the basic white noise here I have, which is this is, I think this one is just the JIT noise. This is just the JIT noise module. Yep, it's just the JIT noise making white noise. And then I have one more noise generator, which is basically a white noise also, but you can control the amount of of pixels you have. So here I have a grid of 16 by 16, and I can change that. And also I can interpolate that, which is kind of cool. So you can have that pattern instead of the squares. And yeah, so basically the noises are the JIT noise object. I'm not making here weird, shader noises, which definitely I can, but um, I just use the JIT noise, which is pretty much reliable, and yeah, and that's the noise. There's another question regarding this.
So not a question related to this just yet, but we have a question about the chemical oscillator.
All right, all right, all right. So the chemical oscillator. I need to delete all these guys. I'm sorry. Um, let me just finish with this, and I'm going to move to the chemical. And I just want to mention here that you can change all the parameters of the feedback loop, and they will create totally different um, aesthetics. Now we have the triangle spinning, and there's kind of a light infinity there, which I made here with the smooth object. And so, yeah, anyway, each thing you change in the feedback loop, it's going to be crazy. So be gentle with the values you choose. And if you don't want to be gentle, just change here the knob range in order so you can have control, because really things in the feedback can go like totally crazy, and then you suddenly don't have any feedback anymore, and it is just because you are displacing things too much. Yeah, okay. So I'm gonna delete all this, and I'm going to go to the chemical oscillator, which is a pretty funky module. Um, Chemical oscillator, right? So the chemical oscillator, you plug it, and it doesn't create anything, because thing here is that you have to trigger the reaction. This oscillator is based kinda on this of the chemical oscillator discovered by Belousov and Sabotinsky. Maybe I can show you. Maybe I can show you this really quickly. If you go to YouTube and you put chemical oscillator, oh, I wrote whatever. So it is here.
Next demonstration is another.
Well, this video is fantastic. It's pretty awesome. Ian's work is great. Anyway, so it's a chemical reaction that make the components of this chemical reaction oscillate between them. There's also a video that shows that the chemical change from, I think it is from blue to red in a certain time, which is kind of crazy. And I thought, okay, the color is changing in a certain amount of time. So what happened if I change the color on a feedback loop? And that's pretty much the basics of the chemical oscillator. I'm going to dive into it in a sec. But here we have the chemical oscillator, which does nothing except you press here the RE, which it stands of reset. The RE is actually a reset button, but in order to give to this a look like a periodic table, I just leave the RE like this. But when you press it, this starts happening. It's a video feedback basically, which is doing itself with a pre-patched video source that this module has. This module works as a generator, but also as a processor. And so in order to use it as a generator, as I'm doing now, it has a video source pre-patched inside the module, okay? So yeah, but you can also, for example, plug the camera to the chemical oscillator, and you are going to start making the reaction with the camera. So now the reaction has the camera as the input, and then, well, it starts doing its own crazy thing. And here you have some knobs. The disruption is going to break your symmetry, and it's going to create these spiral waves. You have a speed button, which basically you can speed up or slow down your chemical reaction here. Then you have the direction. Let's go upwards, downwards. Then you can rotate here. You can zoom in and out. And then you have a speed limit, which, this slows down the whole thing. It's not exactly the same as speed, which speeds up the reaction. The speed limit, it's something that slows down everything. So yeah, that's the chemical, and let me just show you how I get to the chemical, because maybe it's hard to understand if I'm just plugging the module here, but I made this in order to create some complex graphics in just one module. And yeah, but you have to reset this in order to make something. And if you don't want to press the reset button every time, of course you can send it a message like just a bang, it will work. The bang message works. But if you want to do another stuff or trigger it with another thing, I have here also a snippet which is called, in extras, it's called the space bang, which as the name implies, it spits a bang when I press the space bar on my computer. So each time I press the space bar, now I'm resetting the chemical oscillator. Okay, but it is based on the chemical oscillator. It's not that this is a simulation or something like that. So let me just make the chemical oscillator. And the chemical oscillator, it is something like this. I'm gonna grab a Luma key again and make a video feedback chain, and and this should be something like this. I'm going to grab the displacement, and let's start cutting out the whites. So as you can see, there's the feedback, right? I'm going to, so you can make some spatial transformations in order you can see the feedback going on, right? And I'm going to start changing on each iteration of the feedback loop. I'm going to change the color, okay? So for that, I can use the hue modulator or the hue modulator 2, which is this little module which has two inputs. The first input is the image you want to change the hue or the saturation, and the second input is the video source we're going to use to modulate the hue. So let me just plug this here and rotate the hue a little bit. Okay, so now I am changing the colors in each iteration, which should make this rainbow thing. I'm going to increase saturation a little bit. All right. Yeah. So this is really basic stuff. Going to rotate a little bit. Let's just, yeah. I'm going to wrap it. And as you can see, I'm rotating the hue really little here. There's nothing I'm rotating now. But let's see that if I rotate the color, like let's just rotate 180 degrees. So as you can see, the iterations in each iteration of the feedback loop, you are changing the color 180 degrees. So this is going to flicker a lot. So I'm sorry about this. It's flickering so much. And it's not really doing what we want. I think you are going to see something different than what I'm seeing on my machine. But this basically, you can try this later, but it's basically doesn't work because you have a lot of flicker. You're gonna kill someone with this amount of stroboscopic changes. So let's just change the hue like really little, like 9 degrees or less, or even less. And as you can see, the rainbow, start. And let's just, scroll this a little down. And if I, if I change the threshold to the most right value, which is the image is going to be freeze, and it's going to start loop with itself, and the original image, which is my camera, it's not going to be seen anymore, which is something like that. We want to do that with the chemical oscillator. And I think I'm getting closer here. Just going to increase a little bit saturation, and as you can see, there are already some spiral waves forming there, which kind of looks like the chemical oscillator. Yep. And there's something I didn't add here, which is a blur, which I'm going to add it right now into the feedback loop. And whenever it starts, the spiral waves start, I can blur it a little bit, so I can make the spiral waves a little bit, bigger, and then I just turn off the low pass again, the blur again, and you can see all the spiral waves there. And this is the basics of the chemical oscillator. In fact, if I bring this again here, I'm going to add the spaceband object again, and if you read in the middle output, it spits a number that transits from 0 to 1, and it stays in 1. And that's something perfect for what we are doing here with the threshold, which I don't want it to be 0. I want it every time to be 1. So it's feedback with itself all the time, and the original input doesn't appear. So I can say now prepend threshold, and since from the spaceband, from the middle output from the spaceband, it's coming out a 0 that transits to a 1, and prepend threshold. I'm writing this okay. Threshold. All right, there it is. As you can see, every time I press the spacebar, you can see the threshold value transit from 0 to 1, and staying in 1. So yeah, that's the chemical oscillator as a Vsynth patch, the deconstructed patch. And as you can see, the disrupt here from the chemical. I'm just going to add a preview here. Something like this, yeah. So as you can see, the disrupt knob from the chemical oscillator, it is basically the cutoff of my blur here. Let me just adjust this. To make this reaction diffusion system, it won't occur all the time, so you have to fine-tune the modules pretty good. I'm sorry. But yeah, I mean, the spiral waves are coming out from this feedback reaction, and as you can see, they are coming. I can blur them a little bit. And that's pretty much the chemical oscillator, guys. It is basically done by changing a little bit the hue, but rotating, shifting the hue of your incoming image little degrees on every iteration of the feedback loop, and also changing a little bit saturation can do the trick. And you can go to I'm gonna delete the render just for a moment, because I'm going to open the launcher, and the launcher has its own render, and you just need one render to run the system. So if you go to the launcher, there is a patch in the patch rook called BC reaction, which is basically the Belousov-Sabotinsky reaction that I was trying to recreate here. And as you can see, it is, well, I have some other modules here, but it's pretty much the same. I have here a Luma key, the displacement, a hue modulator 2, and a low pass filter. And then it's just some color processors to the end of the change after the feedback loop, just to make this more pleasant, because the chemical oscillator or Yeah, sorry. This this feedback system. I just want to know why it's not working now. I turn off the connectings. Um, the colors are pretty RGB. Pretty saturated, and maybe we don't want that. Um, we want some other colors. So one way to get rid of the RGB stuff, let me just tune this a little bit. Oh, let's see what's happening. Right. Okay. It's getting better. Um, right. So let me just tune this a little bit more so it looks more to the chemical oscillator thing. Yeah. Okay. I think this should be okay. Colors are really important to this. So maybe just if I change a little bit here. Okay, yeah, finally, the spiral waves are there. Okay, so for example, if you want to change those colors a little bit, one cool trick can be converting or scaling these values to YUB. So I'm going to grab the RGB to YUB here, change that, and then actually change the hue now um, of the output of that. So because since the colors of the are of the chemical oscillator or this feedback, let's just grab the chemical. So it's because yeah, because this feedback loop, I mean the it's not that easy to get exactly the spiral waves. So I spend a little time, tuning a lot the chemical oscillator so it works just like a plug and play module. So I'm just going to uh, use the chemical, which it works just fine. Yeah, okay, so as you can see, these colors are really saturated. So when you try to move the hue of these values, there's no much room to rotate. I mean, you can rotate these values to match because they are all really saturated and they are going through red to blue to green to red to blue to green. So you don't have so many grayscale levels or gradients in order to create different palettes. So when you change the colors to YUB, your gradient is changing. As you can see, now we have colors that are at different points in the color space, kind of a chart or grid. And when you rotate the hue of those colors, since there's more distance between them, you can actually get all these new palette out of this. So this is a trick that I use quite often to change colors to YUB and then rotating the hue of that. Uh, it can be by hand or I can grab an LFO here and plug this to the hue modulation input and just open the modulation and let the colors change automatically. Yeah, there's also in the hub files another tab, which is the chemical oscillator tab, which basically explains what I've just said. And that it says that it works like a generator because it has its own pre-patched video source. It can be black and white also. So you can colorize this in any way you want, but it also speeds color because without color, this module won't be possible. So it speeds this color, and it also says that if you connect another video source like the camera, it's going to start making the reaction diffusion thing from the camera. And well, of course, that after the chemical oscillator, I mean, you can do whatever you want. You can, here I just suggesting using a comparator, which it's also known as a threshold, which takes everything to white or to black, depending if your grayscale value or if your brightness of your pixel is higher or lower than a threshold that you can set up here in the module itself. So yeah, that's the chemical oscillator. It was built in order to escape a little bit from the GGL-BFG module, which creates amazing noises, and I kind of use it sometimes. But I think it was, a cool addition, something that comes from the, a really other field. I mean, this is, a chemical oscillation is not something from art. It's not something from sound or image. It's from the chemical world. So I think it was, Vsynth in general, I think it is really interesting and really powerful to study complex behaviors in nature with computer graphics because, it allows you to comprehend a lot of mathematical or problems from other fields really quickly, and this is one of those additions, to expand Vsynth not just to be a video synth or something that makes computer graphics, but something that can be the first approach, your first approach to a lot of other fields. In this case, for example, some chemical reaction, which they are crazy enough to oscillate. So yeah, so that's the chemical. So if there's no, okay, that's
Yeah,
JB there.
it's all right. I'm just going to check in. That was the chemical seems to be an endless source of very interesting psychedelic or otherwise video. I think that the feedback is just very interesting. Other analogy with audio that creates endless possibilities for people making.
Right.
So I have a few questions. There wasn't that many other questions coming our way, but I do have a few more questions. And
Right.
just to clarify, I'm sure you can clarify them very easily. The first one is,
Okay.
how does vSynth work with jitter?
Right. Well, it's just a plug and play thing. Actually, let me just get rid of all this and just the camera. I got the camera. Um, I don't know what. Once again, I forgot. I turned the corner pins off. I'm just gonna change the resolution here, and I'm going to my camera is mirrored, right? Yeah. Uh, so I have here a flip and swap module. Right. Okay. Um, so I mean, there's a lot of ways you can actually plug jitter stuff with Vsynth. Let me just, I don't know. I mean, if you go just here to the Gen Jitter, the shaders that comes with with Max. Let me just add, I don't know, brightness, contrast, saturation here. So I'm just gonna rename this instead of cheatgen, since everything is working here on the GPU. I'm just going to rename this to cheatgl.pix, and I'm going to give to this the name Vsynth as a render context. And now everything is working back again. And I don't remember. Okay, so I'm just going to create a param, which is saturation, $1. Yeah, I'm changing the saturation with a max object, which is a GLPix based shader for changing brightness, contrast, and saturation. I just create the GGLPix and gave to it the name of Vsynth, which is the name of the whole render context here.
Right.
And the same thing happens with VC modules. VC modules, it's even easier. I think I'm
So
gonna
anytime
grab.
you have anytime you have like a video cable, essentially they're interchangeable between Visi, Jitter, and
Mm,
Vsynth.
yeah, yes and no, yes and no,
Okay.
but mostly yes. I mean, here I grab the. I hope this works. I mean,
Okay.
this is
Let
a
me zoom in on you.
this is a duo toner, um, and it's not working. This is weird. This should be working. I mean, let me. Okay, why it's not working? Maybe it just need a black and white image. Let me check. No, it doesn't. This is weird. This should be working. I mean, I've used VC modules with Vsynth several times. So, I mean, let's go to effect. Uh, I don't know. Let's grab an emboss here. Nope. As far as I know, this should be working. Maybe it's not working because
Do you
of the render of
do you need
the
to turn it
launcher.
on?
It
Do
was
you need
turned
to turn
on.
it on? Okay.
Let's just try this again. Yeah, wow, it's not working. This should be working because as far as I know, BC automatically adapts its render context to whatever render context is on executing like at this moment. And in my case, it is Vsynth, which is weird. In
Well,
fact,
well,
I have some
th-
lessons that, yeah, tell me.
this should work are very famous last words. Um, but but it's okay. It's okay. We can explain it a bit later. We have a few more questions coming in from the chat. Is
Yeah,
that's okay?
yeah.
So Tim Thompson is asking, how was the GUI developed? And I think this links to another question that I have about the compatibility with Max for Live, because the GUI reminds me of the Max for Live object. Um,
Yeah, well,
so,
basically, I used uh, the Ableton user interface modules, like the live dial, or all that stuff. Live menu, yeah, yeah, all the live GUI user interface object. I use them all. And yeah, I don't have a license of Ableton right now, but basically you can just copy paste everything into Live and it should work. There are some things you have to take into account if you want
here
to.
are the famous last words again. It should work. But okay.
No, I mean, no, but being serious, I mean, 2 years ago I made this Max for Live plugin, which is also called the Patchbook, and that plugin is a mixer of psynth patches. So basically, you load into your Ableton session this device, and all your patches or all the Vsynth patches you want them to load, and in a real time in a real performance, what you do is to load. You have two scenes, and you load in scene one and in scene two different Vsynth patches, and then you just can crossfade between and patches. Because I mean, there's something that I haven't talked about because it's going to be covered in the workshops anyway. But you can have different scenes here. So you have in one patch a big Vsynth patch, and then you have, for example, another tab in that patch Vsynth with another Vsynth patch. It's the same way I do this in the lessons, which basically you have. Let's grab this one. You have a patch with tabs, and on each tab you have a patch. So this is what I do in a live situation. I just make a big patch with tabs, and each time I'm in one tab, I mute the other two or the other three or whatever tabs I have here to this is just for performance sake. But I mean, if you want to have several patches into one patch, there's an extra little patching you need to know in terms of performance. So because if you have, I don't know, three giant Vsynth patches running at the same times, that will probably break your computer. But if you have just a patch, I mean, I don't know, this patch, which I was working last night, you can just copy paste this into a Max for Live device, and it works magically, but it works.
This is great because then you can connect your Ableton Live performance to some visual synthesis
Right. In
background
fact,
performance.
yeah. In
You, you,
fact,
you
something
should be
something
able to.
yeah. In fact, something that I used to do was to grab a Vsynth patch to live and then create some dummy clips and draw automations and then sync those automations with Vsynth parameters with I don't know the frequency knob or whatever. So I have a session with a lot of MIDI clips with dummy MIDI clips with all automations, and then you just play it and you relax and watch all the automations, controlling your visuals automatically, which is kind of cool.
Sounds great. Well, we have one other question which might be a little long to answer from Gennaro. Can you break down the gen patch for the shapes waveform generator a bit for us? And I have an alternative question for you, and you can choose which one you choose to answer.
Okay.
I suppose over the past 4 years, your pack has been used by many artists, and I was just wondering if you had examples of artists you're very proud of how they used
Yeah.
Vsynth.
Of course.
So you can choose one of the two, or the two. I mean, I'm happy to stay, but it's just for people who are
Yeah, I
watching.
mean, to crack the waveform generators, it's a big thing, but let's just, I'm going to grab the simplest waveform generator, which is something that I don't use anymore. I'm just use it for educational purposes only when I teach the first class of Vsynth. But this is the only, or one of the only modules that still has the complete shader on it. And what I mean by this, when you go to the GTL Pix and you open this, as you can see, uh, basically I have all my waveforms here, and someone who's from audio is gonna be familiar with this because all my waveforms branch from the ramp. So I have the ramp here, and then I have the sine wave, and the triangular wave, and the sawtooth, and the pulse. And yeah, so this is, I mean, if you want to crack Vsynth, this is the patch you should be looking at. But it's pretty straightforward. I mean, you have the normalized coordinates of the screen, then to that you multiply for the frequency, then you have, well, as you can see, it's a lot of really simple math going on because I'm not trying to simulate analog here, which I guarantee can imply more complex things to do. But here it is just, multiplied by the frequency. Then you have a texture input, which is going to be your frequency modulation, which is added to the the frequency here. Then you have the phase modulation, and last the time, which is the speed. Then you make the ramp, which is basically a modulo 1 or a fract to get rid of all the rational numbers and just get with the integers, and split the screen in integers. And but for example, I mean, I can do something like this pretty quickly. From the render, I'm receiving a canvas, which is basically an empty texture. And I'm gonna feed this to a GGL pix called Vsynth, and I'm gonna grab here and put the corner pins. So to make a pretty easy sine wave, I'm just going to get rid of this, the input one, no, in one. So I'm gonna grab the normalized coordinates. I'm gonna switch the x values, the x coordinate values. So I have vertical lines, sine waves in this case. Then I multiply this by the frequency, let's say 2, which is going to create 2 cycles. Yeah, well, this is gonna be, I can add here the time, which I'm gonna create a param here, param time, and I'm gonna set it to 0. I'm going to create the ramp with the fract, or the modulo 1, sorry, just mixing Spanish and English. And let's see what happens here. And I have here the ramp, pretty simple. And in order to get the sine wave, I'm gonna multiply this by 2 pi, and then make the sine of this. I think it's like this. Yeah. So I have the sine there, and as you can see, let's just grab a scope here, and as you can see, the sine wave goes like in audio from -1 to 1, but since in video everything below 0 it's black, you can see that it's clamped at 0, from 0.5 downwards. I guess it's clamping at 0. So we don't want this. So in order to have our full sine wave, the full cycle, the positive and negative values from the sine wave between 0 and 1, we have to offset this result by multiplying this by 0.5 and then adding 0.5. Yeah, and that's the sine wave there plotted pretty quickly. And as you can see, so there are some stuff from this field in particular. As I said, I mean, you can perfectly use the sine wave going from -1 to 1, because, I mean, in fact, I have an oscillator which is called the bipolar oscillator, which goes from -1 to 1, and it's creating the same result as in here. And you can use it as a different, aesthetic, but in order to, if you want to have completely the sine wave between 0 and 1, you have to offset this a little bit. So yeah, so you offset it and you have the sine wave there. And I also, here I added the param time, which is going to be added here. And I have here a module which is only the time, just same time, and it's spitting from the right outlet the timer. So I'm gonna just plug the time here to the module, and as you can see, it's going to the left, which is weird because positive numbers mostly goes to the right and upwards, and negative values go to downwards and to the left. So why is that I'm adding the time and it goes to the left? That's something really GLSL thing there, and it's and since as I was saying, for me, at least in this world we live, positive numbers go to the right. You have here to subtract time to go to the right. So there are a lot of in Vsynth there are a lot of tricks on the user interface in order to make it more predictable, because and that's something I'm really proud about, is that the modules are crafted to the detail. So there are a lot of things that in the feedback loop, for example, that if you change a little bit something, suddenly you lose what you have, and that in Vsynth, that doesn't happen quite often, because you have all these knob ranges controllers in order to adapt the module to the different scenarios of video synthesis, which can be just summing some sine waves, or you can feedback between those sine waves. So but it is crazy, because for example, if I open Hydra, which is a live coding platform that it's kind of it is based a little bit also in synthesizers. I really don't use Hydra, so let me yeah, I think I can start from this patch, this code, I'm sorry. Okay, so it is pretty weird that, for example, in Hydra, you know, it's scrolling to the left. And if you want something scrolling to the right, you have to actually put -1, and that's going to the right, which is, I mean, there are a lot of decisions from the designer of the different tools that for me are really important, and I really insist with details, because I mean, in my case, for example, I don't know. It confuses me, negative numbers going to the left, but I don't know. That's how in GLSL works. So I guess that's why in Hydra this works like this. But in Vsynth, it doesn't work like that. Positive numbers go to the right and upwards, and negative numbers go downwards and to the left, like in traditional, I think Euclidean geometry, or anyway, what was I don't think that I've answered this correctly, but if you wanna crack the Vsynth oscillator, just go to the standard waveform generator to see how it is built, because up to waveform generators 2, as I was saying at the beginning of the streaming, it's not really performant if you have one oscillator executing 6 waveforms, because if you have, I don't know, 5 oscillators on the same patch, there's 5 by, I'm sorry guys, yeah, 30, you have 30 waveforms executing at the same time, and that's super intensive. So for example, in waveform generator 2, you will have all the different shaders as a gensheet file here. And when you change the waveform, you're actually changing the shader on the flow, which is pretty awesome. Thanks very much, Slightly 74, for making this. Changing shaders on the flow, it's really a big game changer. Yeah, and then you have more waveform generators. I mean, there's some. It's always room for more oscillators, and then you have the waveform generator 3, which is pretty much the same as the bipolar, as you can see. These are my new designs. And these waveform generators, I think you're not seeing my preview window. That's a bummer. Yeah, okay. And you have all the waveforms into one shader, and you just have to crossfade here. And it's not the same algorithm of the waveform generator 2, because I'm doing here a lot of other stuff in order to interpolate between all these shapes. But here is another waveform generator that, if you are interested in this, you should definitely check, because this is just one shader, which is doing everything here. And the bipolar waveform generator is pretty much the same as the waveform generator 3, but everything is going from -1 to 1 in terms both of geometry and brightness amplitude. As you can see, if I put a scope here, which I definitely recommend using to understand what you're doing, is to apply a scope and a preview everywhere. So So let me just add another one here. Right. So as you can see, as I was explaining before, um, the sine wave from the left is actually offset and in between 0 and 1, and this other is between 0, between 1 and -1, and that's why we have more values clamped to black, because everything below 0 it's actually black, so we won't see that. We can fix it or change it by with this button here to be offset between 0 and 1 again. But the actual interesting thing about the bipolar oscillator is when you start modulating stuff. Because, for example, I'm going to use a waveform generator tool to modulate the frequency of both oscillators. Just going to stop them. And as you can see, if I modulate the, going to add a preview because we are not going to be able to debug this with the scope. If you turn on the knob of the frequency modulation, as you can see, this it's like it's adding all these new cycles to the right. And whereas in the bipolar waveform generator, since the center of this screen, it's in the middle of the screen and not in the upper left corner, modulation starts from the center and for both sides, right and left. And this is pretty interesting because at the end you can achieve much more easier geometrical patterns. This is mostly, this is basically, yes, this is the same modulation, but one is starting from the upper, let's say that is starting from the upper left corner, and this other is starting from the middle of the screen. And as you can see, they are the same, but yeah, that one starts from the middle to both sides, so it creates this geometrical thing, whereas in the waveform generator 3, this behavior does not occur at all. So, there's always room for more and more creation of oscillators, because depending on the oscillators is the ultimate patterns you're going to make. And yeah, I know that there's a lot of oscillators, and there's also the radial and the shapes that we already seen, the chemical, the AB, and there are more coming, because as I say, there's always room for more experimentation with this. And I go through these first ones that have all the the waveforms as a switch. Then I change to a knob that change all the waveforms in a sweep, and now I'm in the bipolar, which also is a wave shaper, waveform generator, but also it changes its position in the screen and the modulations and a lot of stuff that we are going to cover in the workshops. And to answer you, JB, about the users I'm proud of course I have my top 3 Vsynth users. I'm gonna open here. I'm sorry, but this is going to be on Instagram, okay? So first one is Retro Sex Tape, which is a guy from Iran, which is pretty crazy. I'm from Argentina, and this guy, to which I never met him. I talked to him obviously, but I don't know him. I never even teach him anything about video synthesis. He really made all his Vsynth stuff by patching a lot, and also with the lessons and all that comes with the package. And so what I love about his art is that he's really interested in video synthesis landscape mates, which I have some also, but this is awesome. I really love this one. And he actually uses Vsynth pretty much to make landscapes nowadays. And I don't have any clue on how he made those stairs. That's the truth. I mean, yeah, I mean, he creates some really funky stuff. This human being, it's also made all with Vsynth. I mean, he's one of the crazy dudes like me that likes to do everything with Vsynth. No Macs, no other modules, just, just Vsynth modules. And, I don't know how he creates this little human being here. Just pretty crazy. I don't know. He have made some funky video clips also with Vsynth, creating mixing a lot of different techniques. You should definitely go to Retrosextate Instagram and yeah, and check his art. For example, here is making some reaction diffusion with the title, but then he start processing. With this, you can process video and make generatives. You can also write text. That's something I didn't talk about, but I just want to focus here one sec, and then I go back to the title generator, which is an addition from latest version. So yeah, Retrosextape, it's a great guy. He's making really awesome stuff. If you check this, he's only following Vsynth and LCX Industries. So he's really into only video synthesis stuff. Then you might want to check Clock Logic Instagram, which I have to admit, I talked to him yesterday and I told him I was going to grab this patch and make something like this today, which I did. And which is because I don't know. I mean, I saw this and I said, "Hey, this one is easy, and I think it's gonna be okay for tomorrow." But yeah, again, he's only make. I mean, this account is visual experiments made with Vsynth 74. So this account only uploads stuff made with Vsynth. It's exactly the same than the account I just showed, which is crazy. And this one is also pretty amazing. There are some of them that I pretty much know how they are made, and some others that I don't know. I will have to think a little bit about them. And yeah, then I remember. I mean, there have been users that use Vsynth and then they stop using Vsynth. So, but I remember this was Mike. Yeah, Mike. Mike was one of the first Vsynth users, and he even made visuals with Vsynth for Paramore, which was really crazy some time ago. So I'm gonna scroll down a little bit. Yeah, so this is Vsynth and Paramore in a pretty huge stage, and I don't know. I mean, when I heard about this, I went nuts. I mean, he was using this in a really large stage. So I was pretty happy with this. And there are a lot of users. This is my friend Fran. My friend Fran was one of the he makes audio modular synth, and he was one of the people that was pushing me really hard to hey make this in, hey make this in. And I eventually made it, and in fact he was I didn't have Instagram at that time, so he was the first one actually uploading Vsynth stuff. This is his synth. He has an audio modular company called Nucleo, but this is like I don't know 2016. Yeah, June 2016. It's a really old Vsynth version, but if you knew how to patch, you were able to already make some funky stuff. I remember that at that point I only had one oscillator which only had sine wave and square wave. So I think I learned quite a few tricks these years, and Vsynth is becoming powerful in every update. And yeah, the other guy I want to mention is another Mike. which is this mic. This mic is the guy that was behind the Truchet or the basic Truchet patch. It's in the patchbook now, and I remember he uploaded a story with a screenshot of the patch, and I said, "Wow, he actually made Truchet tiles with Vsynth." And I, sneak a little bit his patch. I copy some stuff, and then I just go by myself and actually build the Tuchet tiles patch that is in the launcher. But this is the guy that inspired me, which I know I love this about the Vsynth community. Might not be huge, but you have some really interesting minds using it. And so I'm pretty proud because they all make some really funky visuals, and each of them has its own aesthetics. So that's really interesting. And I wanna also Danny. I don't remember. Yeah, Danny is a friend of mine who also used Vsynth to make clothes. And well, I don't know, she doesn't upload much stuff, but she actually it's designing and has some fabric printed with Vsynth patterns, which is great because this is not only just for video art, live performance. I mostly use Vsynth as a way to relax and turn on my TV and burst the screen with colors and and yeah, and yeah, there are people that are researching also. There's I just remember something. I'm sorry, JB.
Oh, okay, go on.
You have here. Oh, I really don't remember his Instagram. I really don't remember his Instagram. But Pierre, which is a guy from Colombia, he made a semi-modular video synth with Vsynth modules and actually made a hardware version with Arduino. And it also has a patch bay. So, I mean, it's a semi-modular thing, but it's actually physical. I mean, you can apply cables on it and make the connections, and that's happening in Max. And he grabbed Vsynth modules and create his semi-modular synth. He made the hardware part with Arduino, and he presented as his final thesis. And well, I mean, he creates some really cool stuff. I think they are online. I think Cycling74 even shared that on the Instagram. I really don't remember, but if you are interested, you can just then drop me a line, and I gladly point you out to that physical Vsynth kind of hardware.
This is great. Thank you for sharing the work of people. I think it's inspiring as well for people who want to integrate some visual art to their performance. So it's useful to see the range of things that you can do with Vsynth.
Yeah, I think that people coming from Max, that I mean, that have if you are doing stuff in Max, you mostly have experience with audio synth. And I think that people into the audio synth world can grab Vsynth and make some really crazy stuff with the knowledge they already have. There's no need to, I mean, maybe you just need to go through some lessons and read some specific things about computer graphics or this particular medium. But there are also techniques that additive synthesis, you can relate it to audio, subtractive synthesis the same. And so I think that with a little patching they can just integrate that to their usual setup like pretty easy.
Great. Well, do you want to bring up your face to the forefront? And I think it's time that we conclude this session.
Yeah.
It's been pretty epic. So thank you so much for taking the time to go through the details of Vsynth in preparation as well of the workshops that we will have. If you have watched this and want to learn more, we will have a series of workshops starting next Wednesday, July the 8th. And it's a series of 4 workshops that are independent. You will learn different things every time. If you can't attend all of them, you can attend them separately. And there will be also an option to subscribe and watch the footage later. We record all the workshops, so you can also if you bought a ticket, you can also watch it a bit later. But so yeah, thank you so much for joining from Buenos Aires. I'm here in London, and it's fantastic to build this community across the world, bearing the time zone issues. But I think we did cover quite some territory today.
Yeah, I think too. I mean, I just left one patch that I wanted to show, but it's okay. I can, I can show it to you in the workshops. So I hope you see you guys there. And thanks, JB, again for hosting me here. And yeah, so to the next time.
Great. Well, we do have a forum, forum.musichackspace.org. So if there's any question for Kevin, or if Kevin, if you have patches that you want to point out to
Yeah,
people, you're most welcome to put it out there, or share
right.
it on Instagram, and we'll also continue to share your work. Very happy to have you today. Good luck with all your efforts during this lockdown to get to your next the next phase of your training in America.
Thank you.
And we'd be very happy to have you for these sessions, for these workshops, and as long as you'd like to teach, we'd be very happy to have you again.
Thank you very
So
much. And
thank you
JB.
all for watching. Thank you for your questions, Gennaro, Tim, Eyal, Federico, everybody who followed. It was really nice to have you today, and see you very soon.
Bye bye. Thank you, guys.
Bye, everybody.